In this hands-on video, I will explain how to use and implement IFC Export features in your AutoCAD OEM-based application. The content is organised in a way that will allow you to follow each of the steps at your own pace, helping you implement IFC writing capabilities to an OEM application on your own. If you have not been given access to the IFC Writer Developer package, you should reach out to David Grieve or Ray Bass at TechSoft 3D to get a trial version. Before we can apply the IFC export to our own objects, their properties and data, we'll need to configure the runtime modules in the Writer package. From TechSoft 3D Developer Zone, get the self-extracting archive, eval or production, whichever you are authorized for. Extract the contents to a location of your own choice. Enter the password given to you by us. Now launch the Make Wizard. For learning and R&D purposes, create a new Make Wizard project from scratch. Assign product and company names. This being a training sample application, we better enable everything in the AutoCAD Commands tab. That way we can be certain that we haven't disabled functionality needed by IFC modules to work properly. Add the OEM runtimes and support DLLs in the Your Modules tab. Everything should go in the root folder at this stage. The majority of the DLLs should have Copy File mode. Select the DFMG IFC DLL. This being a mixed module containing both native C++ code and managed code, we need to apply the Bind Managed ARX mode. Select the DFNETIFC and DFBIMAPI DLLs entirely written in managed code. In the Your Module Settings tab, assign the local names and load control values for each OEM runtime. The logical names would be equal to those of the runtimes, except the mix module, which should be named DFUtils. The order in which the modules are loaded is critical. The DBX module, being native, will be loaded first with a load control value equal to 2. Same value for the mixed module. However, the loading order of the two other ones can't be guaranteed, so we will have to load them in a different place to make sure DFBIM API is loaded first. Assign the value 4 to both. Add the QBIM command for the DFNet IFC module. This will be handy as you can then view and examine the tree structure of your IFC export being generated in the BIM Manager palette. To take care of the loading of the DFNet IFC and DFBIM API DLLs, we will do that in the S::startup function of our application. As this is a new project from scratch, in other words, I don't have the startup function from before, I'll need to create the file and add the function to my host.lsp file. Make a copy of the AOEM version of the file. Add the S::startup function and make sure to load the DFBIM API DLL first, then the DFNet IFC DLL, which will link itself to the BIM API DLL when it is loaded. To make this run properly in the OEM application, we need to rename the file according to the assigned hostname found in the Program Name field of the Project Information tab. Then we need to compile the file into FAS. If you're not familiar with this step, it is described in the OEM Developer's Help, whether you use Visual Studio Code or the legacy Visual Lisp IDE. Add the new FAS file in the Make Wizard. Use Bind List mode and place it in the Support folder. Now we're ready to build. Let's run and see that it works. Type QBIM and verify the BIM Manager window is displayed. Close the BIM Manager and the application. What we have done so far has merely been preparations to be able to implement our own custom IFC export from DWG content. Now let's look at what needs to be done to apply IFC protocol data to our objects and distribute them as an IFC file. For this, we have prepared a Visual Studio sample project. Go to the Training tab on TechSoft 3D Developer Zone. From the IFC Export drawer, download the BIM extension sample project. Extract to a location of your choice. From Visual Studio 2019, open the BIM ext app 2021 C# project. Choose the debug_df configuration. Replace the object ARXDLL references with local ones. And the DFBIM API reference with the ones you extracted from the IFC Export archive. Make sure to set copy local false for all reference DLLs, as there already will be runtimes of these in our OEM application. Let's look at some of the content. We won't go into detail here. It's assumed that you are familiar with C# as well as Object ARX. In the Examples folder, there are a few sample scenarios implemented. The other folders contain UI elements for the different commands and XAML user controls to assign and access the different IFC properties that need to be applied. The My Command source file contains all the declared commands. Compile the BIM ext app DLL, go to the Make wizard, add the DLL, target the root directory, add the commands from My Command source file, assign the local name as the namespace where the commands are being declared. One way to do it is to copy it straight from Visual Studio like this. Logical control value 12 for manual load or command invocation. Build the OEM application and launch it from the Make wizard. Type IFC at the command prompt to get a list of all the commands. Select the command IFC Create Simple Project. Go back to Visual Studio and look what the command does. It seems like an IFC project with a 3-story house. Go back to the OEM application and type QBIM to launch the BIM Manager. If we examine the tree structure, we can confirm that the IFC project has been properly created. But if we look at the nodes, we see there are no graphic objects yet. Close the BIM Manager and the OEM application. In Visual Studio, Properties, Debug, set our OEM application as target for debug sessions. Set a breakpoint in the command IFC Create Room example, start debugging. At the command prompt, type IFC Create Room example. The breakpoint should now be hit. We can step through this example and see what it does. The project and site. Walls for the room. Graphical objects. Material and properties. Hit Continue to finish the command. We can see that a room has indeed been created in the drawing. In the BIM Manager, we can navigate the IFC content we created. We can identify objects in the drawing from the tree structure and locate nodes in the tree from drawing entities. The values all match what we saw debugging in Visual Studio. To create an actual IFC file of the room project, we run the IFC Creator command. This is a dialog that covers all functions in one place. It also offers a save file function. Create an IFC file locally on disk. Let's view the file in a text editor. You recognise the values and properties from the source code when we were stepping through the debugger, and what the BIM Manager tree view showed. Confirm the IFC content by starting a new drawing in the OEM application. Import the newly created room project. See that we have the 4 walls and IFC properties that we just exported. Using the BIM API, you can also read an existing IFC file into the session. Make corrections or apply changes to the IFC model using AutoCAD OEM and custom features. This is a Vectorworks sample IFC file. Imagine that there is something that needs to be reviewed and possibly altered. Even add new items. There's no limit really, as long as the CAD engine and customization API can do what you require. With BIM API access to the entire IFC project, it would now be easy for us to apply those changes and produce a revision of the original file. We don't have a prepared sample for that scenario, but to exemplify what I'm suggesting, I can use the limited editing features of the BIM Manager. I look up an IFC object by picking one in the drawing. The picked window is located and selected in the tree structure. Using the Info button, I can access the IFC properties from the selected node. In the Common tab, I can assign some basic properties to the objects in the tree model. By bringing up the IFC Creator window from our BIM X App sample application, I can now save the model back to a new file. I copy the global ID from my window node, bringing the new IFC file up in an editor. I look up the node. We can confirm the changes I made are now in the file. A quick look at the original file to confirm the difference between them. The BIM API and the sample application documentation can be found in the Doku folder of the Learning Sample Archive. There is a documentation for the BIM API. The BIM X App sample application, and how to get started. Make sure to read the introduction and installation chapters to understand how to get started. If you need to learn about the IFC standard, documentation can be found at the Building Smart website. Thank you for watching. I hope you find the material useful. Hang on. I believe we have a comment from one of our viewers.
Blimey, that is bleeding easy, isn't it, Governor? Why, that's as easy as landing a job as a UK lorry driver at the moment. It's as easy as finding a cosy pub around here. It's as easy as finding a free ticket to a city match, that is. Gobsmacked I am. Gobsmacked.
Indeed it is, Mr. Fritz.
Oi, mate, another?
Indeed it is.